We're going to start here with number 25. Who asked that? Did Riley ask that? That's weird. That's weird. We started with somebody that wasn't there asking a question. All right. So they've, I don't know why. This book likes to put these ones in there. They're going to say, let u equal root x plus 1. And then they want to have us rewrite this integral of the integral from 0 to 3 of dx over x root x plus 1. So basically all they're checking is that, one, when you change it in terms of u, do you know that you need to figure out what dx is? So, du is 1 over 2 root x plus 1. Right, so how are we going to get that? We got to figure out how we're going to get that in there. I'm changing the dx into the du. And then the other thing they want to check is, are you able to get this x over here in terms of u? So, u squared equals x plus 1. So x would equal u squared minus 1. And the other thing they're checking with this is that they want to see if you remember that you need to change your limits of integration. So if you're starting at 0, it needs to become, if x is 0, then u needs to be 1. And if x is 3, then u needs to be 2. So they're basically saying, all right, are you able to do all of these many things to convert this into a different integral? So basically what you got to do then is rewrite the integral. So 0 to 3 becomes, I don't know what it's doing. It becomes an integral from 1 to 2. And then our, I put my dx there. Our dx needs to become 2 root x plus 1 du. So if we solve for dx to see what that is, right? dx is 2 root x plus 1 du. So I can replace the dx with that. And then in the bottom, we've got an x, which we know is u squared minus 1. And I'm just going to write the root x plus 1 there because, well, what happens with the root x plus 1 and the root x plus 1? They should cancel out. So we should end up with an integral from 1 to 2 of 2 du over u squared minus 1, which looks like that's choice B. Does that make sense? Yeah. Just make sure when you do your u subs that you make sure you get rid of the dx and turn it into du. Make sure that if there's any other terms, you're able to solve for them, and make sure you, most importantly, change the limits of integration. Well, not most importantly, because if you don't do any of those things, then you're going to be wrong. But the one people most often forget is changing the limits. Sure. Other questions? For 27, use capital M 3. That's not a notation they would ever use on the AP test. They would write that out. I assume they're meaning using the midpoint rectangular approximation with 3 subintervals is my guess. I can, is that, yeah, I mean, let's see. Does it say what answer choice it's supposed to be? Let's see if we get D if we do that. So 27 says this weird notation M of 3, which is not a notation, like I said, that they never use on the AP test. So we're going to just do a midpoint rectangular with 3 subintervals. And we're doing the function 6x minus x squared from 0 to 6. Right? So 6x minus x squared from 0 to 6. So our subintervals will be 0 to 2, 2 to 4, and 4 to 6, which means that our midpoints will be 1, 3. I don't know why I wrote a 5 there, but 1, 3, and 5. And the length of each subinterval will be 2. So the midpoint of 0 to 2 is 1, like we said. So the height of the function at 1 is 6 minus 1 is 5, right? Times a length of 2. And then the midpoint of 3 ought to be 18 minus 9. And 18 minus 9 is 9. Still a length of 2. And then at 5, it ought to be 30 minus 25, which ought to be 5 again. So it looks like that is 38. Is that what you said it should have been? Based on the answers. Perfect. Everybody good with that? People in the Zoom, are you good with that?
Yup.
What? Oh, what? What? Yeah, you're good?
Yes.
Oh, good, okay. I mean, yes, it is easy to just integrate that, DM, but the question is asking you to use a midpoint rectangular approximation with 3 subintervals to approximate that value of that area. So if you just integrate it, you'll get the wrong answer, I assume. Otherwise, yeah, I mean, you'll definitely get the wrong answer. They're specifically asking you to approximate it. Other questions from the definite integral? 33. Yeah, we do 33. Hopefully. 33 says the average value of the square root of, what is it, 64 minus x squared on its domain. Yeah. So what is the domain of square root of 64 minus x squared? What's the domain of square root of 64 minus x squared? Yeah, the domain of this ought to be -8 to 8, right? I mean, 64 minus x squared has got to be greater than or equal to 0 for us to be able to square root it. So x squared has got to be less than or equal to 64. Well, that's going to be between -8 and 8. So this becomes 1 over 8 minus -8 times the integral from -8 to 8 of the square root of 64 minus x squared. This integral might be one that you'll have some difficulty trying to solve. Is that what the problem you had was with this, and you can evaluate that integral? Yeah, so one of the things that we talked about, we did like one problem like this a long time ago, was that if we wanted to figure out what this integral was from -8 to 8, well, what is the square root of 64 minus x squared? What does that graph look like? What? It's a semicircle, right? So this is just a semicircle from -8 to 8. It's a semicircle with a radius of 8. So the integral from -8 to 8 of square root 64 minus x squared is just the value of that area. And so that's just a semicircle, 1/2 pi r squared, with r equal to 8. So it ought to be 1/16 of 1/2 pi times 8 squared. So you don't actually have to integrate it. You just need to recognize that that's a semicircle and then use the geometric formula for it. So what does that give us? That gives us 2 pi, I think. Does that make sense? Yep. Yeah, so if you come across an integral like that you definitely don't know how to integrate, it will likely be a calculator question, or it will be something that's geometric that you can find the area of it. Everyone good with that one? Zoom, are you good with that one?
Good Zoom.
Good Zoom. All right, we got a question from the chat in the Zoom. Number 24. Let's see here. 24. Oh, it's similar to what we were doing a minute ago, huh? All right. If we let x equal tangent theta, what is this integral become? Well, so 1 to √3 of √1 plus x squared. Yep. Okay. So our substitution is that x is tangent theta. That's what they've told us to use. That would tell us that dx would be secant squared theta d theta. So we should be able to go in and just evaluate these. So we've got the integral of, well, let's see, √1 plus x squared will become √1 plus x squared. Everybody good with that? Yeah. And then dx will be secant squared theta d theta. And if x is 1, that tells us that 1 equals the tangent of theta. So what is the theta value where that's true? Pi over 4. And if x is root 3, that tells us that root 3 equals tangent theta. And what is the theta value that makes that true? It's very important that you know the values of tangents at, like, you know, pi over 6, pi over 4, pi over 3, pi over 2, all of those regular unit circle values. You should know all those values of tangents. It's pi over 3. And so, I don't know, is it, yeah, I assume that's not one of the answer choices because they wanted you to simplify this square root of 1 plus tangent squared theta. What's the square root, or what's 1 plus tangent squared theta equal? That's a Pythagorean trig identity that you should know. What's 1 plus tangent squared? Okay, remember there was this paper I put up in the Google Drive. It says required trigonometric identities. And I've said this like 50 times this year. You need to know those required trigonometric identities. What is 1 plus tangent squared theta equal to? It is
Secant squared.
Secant squared. Great. So the square root of 1 plus tangent squared theta ought to be the square root of secant squared, which ought to be secant theta. So this is secant theta. I have secant theta times secant squared theta, which ought to be secant cubed theta. Everybody good with that? Any questions on that? Everyone's good? Yeah? Matthew, you good with that one?
Yeah, all good.
Oh, wonderful. Other questions? $44? 44. We've got g of x is equal to the integral from 0 to of f prime of 3x dx. And we want to know, what does g prime of 1 equal? All right. So, is that right? Is that what it says? I looked at, oops. I looked at half of 43 and half of 44. Sorry. Just f of t dt. Yeah? What? So it's 2x in the limit? I can read. F of t dt. I have the right problem written down now. G of x, 0 to 2x, f of t dt. Yeah, that looks right. Okay. G prime of 1. So this is the first part of the fundamental theorem of calculus. So if we are given g of x and we want the derivative of it, we just need to take a derivative. So now we're looking at the derivative of both sides. So the derivative of the left, that's our g prime, right? G prime of x is, well, the derivative of the integral of a function from a constant to a function is the function that's inside f, evaluated at the upper limit, times the derivative of that upper limit, which is 2. So that's 2 f of 2x. And the 0, that's the constant in the bottom, disappears when you take the derivative of it, right? Because you're taking the derivative of a constant. And so g prime of 1 ought to be 2 f of 2. Oh, and then they tell us to use the graph that's up above, right? There's a graph. I'm going to say there's no way to get a value from that. They give us a graph that looks like this, which is the graph of f. So 2f of 2, well, they give us this point up here is the point 2, 4. So 2f of 2 ought to be 2 times 4, or 8. Choice D. Yeah, that's fine. Okay. Yeah, good. We're go with that? For a second, I was looking at choice E, but that had nothing to do with it. Any questions there? Choice E on that one says that it doesn't exist because f is not differentiable. It's fine if f is not differentiable, right? Because you're not taking the derivative of f. You're taking the derivative of g. F is not differentiable at 2 because it's got a part. Everybody go with that? Other questions? There are multiple choice questions. Sarah, no more questions, that's it. Oh, we got one in the chat here. 36. 36. We're doing that a lot today. Making these fun sounds all day today. That'd be great. All right, 36. Choose the Riemann sum whose limit is the integral from 1 to 5 of x cubed dx. So we remember that in order to convert from a definite integral to the limit of a summation, it always is the limit as n approaches infinity of a sum from k equals 1 to n. And then it is always f of x sub k times delta x. And this is all on that sheet of things that I posted in the Google Drive that is like, it says A/B test reminders. All this information is in there. So you wanna go back and remember all of this. But we'll remember that delta x just represents the length of one of the subintervals. So the length of one of the subintervals is the entire length of the interval, 5 to 1, 4, divided by the number of subintervals, which is n. So delta x is always b minus a over n. So we get 4 over n. And then x sub k is always your lower limit, a, plus k times your delta x value. And so delta x is always b minus a over n, and x sub k is always a plus k delta x. And so we'll just plug those things in. We got a limit as n approaches infinity of the sum from k equals 1 to n of x cubed, right? It's x sub k cubed, so x sub k is 1 plus 4k over n. Cubed times delta x, which is 4 over n, which should be choice choice A. Yeah, choice A. No, it's choice C. I know how to find the 4 in there. Choice C. Good with that? Everybody good with that in Zoom?
Yeah.
Wonderful. Other questions? Everyone's good. That's it from the definite integrals. Anybody else in the Zoom? Otherwise, we'll go start with some of those free response questions that I asked you guys to work on. All right. Okay. Couple of things that they tell us. 1, this is a semicircle. 2, the rest of these things are line segments. Great. We want to find f of -6, And we want to find f of 5, and they give us an initial condition that f of -2 is 7. They also tell us this is the graph of the derivative of f. So all of that is important. If we want to find the value of f of -6, we need to take our initial condition, which is that f of -2 is 7. And then add to that the integral from our initial position, or our initial condition of -2, to -6 of f prime of x. And normally we don't, when we're trying to figure out the area on a graph, we don't like to have the lower limit be a larger value than the upper limit. So we'd like to rewrite this as 7 minus the integral from -6 to -2 of f prime. Everybody go with that? Yeah? Yeah, y'all are good. All right. And then what's the integral from -6 to -2? Well, that's just the area underneath the curve from -6 to -2. That's just a triangle. That should be 1/2 base times height. That's the height of 2 and a base of 4. So 1/2 of 2 times 4 is 4. Everybody go with that? So f of -6 is 3. And then to find f of 5, we'll do the same basic thing. F of 5 ought to be the initial condition, 7, plus the integral from -2 to 5 of f prime. Well, to go from -2 to 5, part of that is the semicircle, which is below the x-axis. So that ought to be negative. So 7 minus 1/2 pi times the radius. What's the radius? 2 squared. And then plus 1/2 of 3 times 2 for that triangle. So just plus 3. So we end up with what? 10 minus 2 pi. Everybody go with that? No issues, no questions, no problems there. Everyone's good there? Because the lower limit always has to be this value that we know. Right, so the lower limit always has to be -2 or 0 if we start at 0, if they tell us f of 0 is something. Because we are looking for the area. If we're setting up an integral to find some other value, we are looking for the area from the value that we know to this other value, and then having to add the initial condition of the area to that. Does that make sense? And so then, because the upper is less than the lower, we flip them. All right. Everyone's good? People at home, Zoom, are you good? Zoom, good?
Yeah.
Good, Zoom. Okay. On what intervals is f increasing? So f would be increasing if its derivative is greater than, technically greater than 0. Now, this is my favorite. This is my favorite thing about the College Board. Read into that as you want. This is my favorite thing about the College Board. My absolute favorite. The thing about them that I love the most is that I don't have it up now, but I remember looking at the scoring guidelines for this, like last quarter when we were doing this one. The scoring guidelines say f is increasing when f prime is greater than 0. Okay, great. So we look for when is f prime greater than 0. Right? When is that? Well, that's from -6. Close bracket, right? -6. It's above, for sure, at that point. And then they say to -2, and then they put an open parenthesis, which makes sense because that's when f prime is greater than 0. It's not at it's not at -2. It's 0 at -2. Then it's positive again from 2 to 5. Both of those with open intervals, right? And then they say, well, so f prime increases on, and then they put this, -6 to -2 with brackets, union 2 to 5 with brackets. That's what the scoring guidelines for this problem say, which is just the most idiotic thing I've ever heard in my life. They put parentheses for when the derivative is greater than 0, which tells you when it's increasing, then they put the intervals in brackets. Doesn't make any sense. So they even recognize that f prime is, when f prime is positive, that's when it increases, not when f prime is greater than or equal to 0, just when it's positive. But then they say that it increases on the closed interval. I don't know what to tell you. Put the intervals themselves in brackets for increasing and decreasing. Everybody good with that? For increasing and decreasing, you mean? You should put parentheses if it's like going towards infinity. Like if it was increasing from 2 to infinity, you'd put the infinity in parentheses still. Suppose this was an open circle here, and then we're saying that point doesn't exist. Well, actually, suppose, okay, so this function is supposed to be f is supposed to be increasing, right, from -6 to -2. Right, suppose at -2 you had an open circle on f though, then you'd put it still as a parenthesis because that point doesn't exist. But as long as the point exists, you are supposed to put it as a parenthesis. According to the College Board, not according to me. But since the College Board grades your tests, not me,
And so we need to state both when the derivative of, or when f prime is greater than 0 and when it is increasing, or when f is increasing.
You need to, yeah, thanks. Yeah, I meant to say f increases, right? Not f prime increases. Yeah, you need to say that, you need to at least say that something like f increases when f prime is greater than 0, and then you can just write your answer. You don't necessarily need to put the interval when f prime is positive. You could just put when f increases, as long as you make a statement that f increases when f prime is positive. Does that answer your question?
Yes, thank you.
Sure. Other questions on that part? Everyone good there? Everyone's good? All are good? 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 Zoom, good? Great. Find the absolute minimum of f on the closed interval, -6 to 5. So when we talk about an absolute minimum, it could occur, if it's a closed interval, at either a place where there's a local minimum, so a place where the derivative is 0, or where the derivative is undefined, or it could occur at an endpoint. So we need to check our endpoints. We need to check -6. We need to check 5. And we need to check any place where we might have a local minimum. Well, a local minimum, that looks like men, sure. A local minimum occurs if f prime goes from negative to positive, doesn't it? Because if f prime goes from negative to positive, f goes from decreasing to increasing to give us a local minimum. So when does f prime go from negative to positive? Well, it goes from positive to negative at -2, so I don't really need to worry about that. That's a local maximum. And then it goes from negative to positive here at 2. So in order to figure out the absolute minimum, we need to check the value at -6. We need to check the value at 2, and we need to check the value at 5. Now, we could be pretty certain here that it's not going to be f of 5. We already have the value for f of 5, though. What's the value for f of 5? 10 minus 2 pi. And what was the value for -6? We had that too, right? 3. We can be pretty sure it's not this value at f of 5 because, well, this value down here that made us negative is going to be smaller than the value after we've added some positive area in. So really that 10 minus 2 pi we don't even need to worry about. But we do need to figure out the value at 2. And so the value at 2 ought to be 7 plus the integral from -2 to 2. of f prime. And what was the value of the integral from -2 to 2? That was your semicircle, so 7, and it was below, so 1/2 of pi times 2 squared, so 7 minus 2 pi. And then we'll note that 7 minus 2 pi is definitely less than 3. So our absolute minimum is 7 minus 2 pi, and it occurs at x equals 2. Good or no? You would show all this work. Yeah, I mean, it doesn't specifically say justify your answer. Yeah, I mean, you'd write out something. You'd write this. You'd say a local min occurs here, and so you'd say that's why we choose 2. And then you'd say we also have to check the endpoints. And then you'd write, and then just writing these values is good enough. And then circle the one that's the smallest. Good. Everybody good with that? Any other questions on part C? Is that part C? Yeah, part C. All right. Part D for f double prime of -5 and f double prime of 3. Find the value or explain why it doesn't exist. So these should be the slope of the derivative at -5 and the slope of the derivative at 3. So for -5, the slope of this thing at -5 is just the slope of this little linear piece. What is this? -1/2, right? And what about f double prime of 3? Does not exist. It's a corner. If you want to be more specific, saying it's a corner should be good enough. But if you want to be more specific, you can say from the left, the slope is, some positive value. From the right, the slope is some negative value. This is what is that? Negative, it's +2. And then this slope over here is -1. And so from the left and from the right, the slopes don't match up. They're not going towards the same thing. Good? Any questions there on part D? People at home, you all good there?
Yeah.
All right. And you guys did this one also, right? Yeah. How'd this one go? Okay. What is this? Okay. All right, this is just piecewise linear. So we got a bunch of little line segments here. Six different line segments. And we are given a function for g. G is the integral from 2 to x of f. So sometimes they give us an initial condition like they did in the last one. Sometimes they don't give us that initial condition. They just tell us where we need to start. They say, when you're looking for these areas, start at 2. Okay? So then the question is, does G have a relative min, max, or neither at 10? Well, G has a min or a max if its derivative changes signs. So what is the derivative of G? G prime is f, right? G prime is f based on the first part of the fundamental theorem of calculus. The derivative of the integral from a constant to x of a function is just that function. So we look at f at x equals 10. What happens to f? Touches the x-axis, but then stays negative. No sign change. So we would say neither, because G prime, which is f, doesn't change signs. At x equals 10. Good? Everybody feel all right about that? Part B, does G have a point of inflection at x equals 4? Well, when you talk about a point of inflection, that would mean that G double prime needs to change signs. What's G double prime? G double prime ought to be the derivative of G prime, or the derivative of F. So G double prime is F prime. And there is often on the AP test points associated with just writing out that G prime of X is F of X, and that G double prime of X is F prime of X for each of these problems. So make sure you write out that relationship between G double prime and F prime, that they're equal. So now we're looking for a sign change of the derivative of F at 4. Well, what's the derivative of F to the left of 4? Two, right? What's the derivative of F to the right of 4? -2. Is that a sign change? Yep. Did that sign change occur at 4? Yep. So yes. And you'd say G double prime, which is F prime, changes from positive to negative, or from +2 to -2 at that point. Therefore, G has a point of inflection because of the second derivative sign change at that X value. Good or no? That sounds good. All right, part C. People in Zoom are going to be?
Yeah.
Great. Yeah, one. All right. Part C, find the absolute minimum and the absolute maximum of G on the interval -4 to 12. Okay. Well, where can an absolute min and an absolute max occur on a closed interval? At the endpoints, right? They want us to go all the way -4 to 12, right? At the endpoints, where else? Any place where G prime equals 0, or potentially where it's undefined, but it's not. So G prime is 0 if F is equal to 0, right? But it also has to cross through the x-axis, doesn't it? It can't just touch and bounce. So at -2, it crosses through, so there's another place we'll have to check. At 2, it touches the x-axis but bounces off, so we don't need to worry about checking 2. At 6, it crosses through. We'll check that. At 10, it bounces off, so we don't need to check that. And we need to check 12. So we got -4, -2, 6, and 12. Sound good? Then we just need to figure out G of each of those values. Well, G of -4 ought to be the integral from 2 to -4 of f of x. And what are we going to do with that in order to find that value? Flip the limits. All right, now just to make our lives a little easier here, what's this area right here?
Four.
4. What's this one here?
8.
What's this one?
8.
What's this one?
8.
And what's this one?
4.
Great. And all the ones that are below are going to be negative. So -4, -8, and -4 there. So if we're looking for the integral from -4 to 2, well, from -4 to -2, it's -4. And then from -2 to 2, it's 8. So those will cancel out and become 4. So at, what is it? We're looking for G, right? G of -4 is the opposite of 4. What about G of -2? That ought to be the opposite of the integral from -2 to 2, shouldn't it? Which is -8. Yep. And then if we want the value of, what was the next one? 6, that's the integral from 2 to 6 of f, which ought to be +8. And then the value of the integral from 2 to 12. Well, that'll be 8 minus 8 as 0. Minus 4 ought to be -4. Everybody good there? What's our absolute minimum? Oh, yeah. Sorry. Sorry, that was G of 6. What's our absolute minimum? Our absolute minimum is -8, which is at x equals -2. And our absolute max is 8, and it's at G of 6. Goodbye, whoever left the Zoom. There's still 24 minutes of class left. Everyone good there with C? All right, we want to find for G all intervals in which G of X is less than or equal to 0. Okay? So how do we figure out when G of X is less than or equal to 0? Well, G prime is F, right? We want to know when is G less than or equal to 0. So you're sort of looking at that backwards, right? We just need to figure out when the value of this integral, right, the integral from 2 to x is less than or equal to 0. Well, we know that at 2 it is 0, isn't it? So at 2 it equals 0. Well, from 2 to 6, it's not negative, is it? Positive. And then all the way from 6 to 10, I'm getting rid of that positive 8 area. And by the time I get back to 10, it should be, if I go from 2 to 10, what's that integral? 0. So then the rest of this, which is negative, is when G will be negative, right? So we know that from, it's at or equal to, right? So that'll be from 10 to 12. G. And then we also have to look over here. Well, we knew that at -4 it was negative, right? Yeah. G of -4 was -4. And then let's see, it ended up being what over here? This was also still negative, right? Like at -2, it was even more negative, -8. And then we added in some positive 8 then, which made it eventually get to be 0 here. So from 10 to 12 and from -4 to 2. Uh-huh. Because G of X is the integral from 2 to X. We're starting at 2. Does that make sense? Or no? Are you sure? The tone of your voice indicated not, so. I have to start at the lower limit. So it's starting at 2, going to the right if we're going 2 to 10. So 2 to 10, we've got 8 by the time we get to here, and then by the time we get back to here, we're now in 0. Does that make sense now? Other questions from that? Everyone good? I had you do this one also, right? This is the last one I had you guys do from these. All right, we've got f prime drawn here, which is the derivative of some function f. It's twice differentiable, very exciting. We know that we have horizontal tangent lines at -1 and 1 and 3, right? And we know that the areas of the regions bounded by the x-axis and f prime from -2 to 1 and 1 to 4 are 9 and 12. Both below the x-axis, so technically, the integral from -2 to 1 would be -9. The integral from 1 to 4 would be -12, right? we want to find all x coordinates at which f has a relative maximum, right? Okay, so when can f have a maximum? If f prime, right? Yeah, f prime changes signs, or if f prime is 0, right? Well, when f prime is 0 and when it changes signs. So f prime, let's see, what is it? Maximum, right? So f prime has to go from positive to negative here, which, well, that's happening at -2. It's going from, we'll say f is going from increasing to decreasing. That's at -2. So we'll check at -2. That's a relative max. What about here at 1? We're going from positive to negative for f prime. Negative to staying negative. And what about at 4? Still negative. So if we think about what does the graph of f look like, f is increasing from -3 to -2, and then it is decreasing from -2 to 4. And even the endpoints here, because it does say on the closed interval, right? Those endpoints are both local minimums, not local maximums, right? If I started off like this, then that endpoint would be a local max, but I didn't start off that way. Does that make sense, everyone? Zoom, you're good with that?
Yeah.
Wonderful. All right, next thing we want to know is on what open intervals is the graph of f concave down and decreasing? So if f is concave down and decreasing, well, if it's decreasing, f prime must be less than 0. And if it's concave down, f double prime would also be less than 0. So the derivative of f has to be negative and its derivative has to be negative. So when is f prime less than 0? Well, -2 to 4. Yeah. Not at 1, but we'll worry about that later. F double prime is less than 0 whenever the slopes are less than 0. So whenever the slopes are negative. Well, are the slopes of this thing negative from -3 to -2? What about from -2 to -1? Yep. What about after -1? -1 to 1? No. So this is true -3 to -1. And then it's also true again from 1 till we hit this local minimum. 1 to 3, and then they go back to being positive again. So what's the overlap of -2 to 4 and 1 to 3? Well, looks like that ought to be -2 to -1, and then 1 to 3. Everybody good there with part B? Question? Amateur, comma. Yeah, I don't know. My hand doesn't seem to write the things that my brain is thinking or saying. I said the right thing. I'll guarantee you this, 100% of the time, I will either write, say, or think the right thing. Guaranteed. I will 100% of the time, one of those things will be right. Usually not all three at once. I'll usually like, I mean, 100% of the time I'll think the right thing. And then like, I give it 95% of the time, I write the right thing. Maybe like 98% of the time I say the right thing. But good news is I'm always thinking the right thing. You can always be sure of that. Any questions on A or B? Yeah, it's fine. You guys okay there? You all right? Is there something wrong with the bottom of your shoe? I don't know, she's like picking at the bottom of her shoe. Did you like step in gum? How's the bottom of your shoe look? Great. That's reasonable. It does walk around on the ground. Is there something else about her shoes? I don't know. They just like, they're just, you all were like both laughing very much about the shoes, weren't you though? Her health? Should we be worried about her health? She had a green rectangle. Okay. Don't worry, Zoom. Everybody here is fine. I know you were very concerned. Weren't you? Weren't you all very concerned?
Yes.
Perfect. All right, part C. Oh, yeah, you got a question now?
Difference between like the right side up view and upside down view.
Yeah, the upside down or the right side up view, the one that I drew there. Yeah, the one that I wrote here is called union. That's a union. The union is this or this, right? So you know, on either -2 to -1 or on 1 to 3, this thing is true. The upside down view, that means the intersection of. So that means that both this thing and this thing both have to be true. So like that obviously wouldn't have. So what we would say is, we would say that the solution to this is the intersection of -2 to 4 with -3, -1, union 1, 3. So you know, the intersection of this set of numbers and this set of numbers is this set of numbers, which is our final. That makes sense? Yeah. No, we don't. I mean, it doesn't get a lot of use until, well, I mean, yeah, it doesn't get a lot of use unless you're doing like number theory stuff for the most part these days. You're not ever gonna have to use it. Yeah. I'll put it there just for fun. That way I can look really mathematically brilliant. Good, everyone's good? Other questions on that? Okay. Part C. Find the x-coordinates of all points of inflection for the graph of f. So we're looking for points of inflection. Yeah, if we're looking for the points of inflection of this graph, we need the second derivative of f to be changing signs. So we need f double prime to change signs. So then we'll look at, when does f double prime change signs? Well, that's the slope of f prime, right? So the slope of f prime goes from negative to positive here at -1. Yeah. Oh yeah, sure. And then it goes from positive to negative here at +1. And then it goes from negative to positive here at +3. All the places where we have these horizontal tangents to f prime. So we would say points of inflection, what was it, -1, 1, and 3. And we'd say it's because f double prime changes sign thing. Everybody good with that? And then part D, given that f of 1 equals 3, write an expression for f of x. So if f of 1 equals 3, then that tells us that the integral from 1 to x of f prime plus 3 ought to be f of x, right? That's what we've been doing with the other problems where they gave us this initial condition right after that. We said that the integral from that original position of 1 to any other x value of that function plus any 3 value, right? We have to add that 3 in because that's our initial value at f of 1. Does that make sense, everybody? And make sure you change those to t's. When you put in an x in your upper limit, don't write f prime of x dx. Make sure you write f prime of t as t. You can do it something else. So you can do like f prime of theta d theta or something if you wanted. Usually we use t. Everybody good there? And then it said to find f of 4 and f of -2. So f of 4 ought to be 3 plus the integral from 1 to 4. Well, what's the integral from 1 to 4? That is -12, right? So 3 plus -12, that's -9. And then we also wanted f of 2 and negative 2. So that ought to be 3 minus the integral from negative 2 to 1. Right? Flip the limits, change that sign. Right? And so that's 3 minus, well, what is the value from negative 2 to 1? That's a negative 9. So 3 minus negative 9 ought to be 12. Everybody good there? Any questions on that? Everyone's good? Those of you with the May 24th test, that's 2 weeks from today. Are you all excited? Who's May 24th? Wow, look at you all. It's very exciting. Like this? Yeah, I mean, you should write f prime of x dx or f prime of t dt. I don't think they'd knock you down for that. They might, but well, they won't knock you down. But they might knock off a point. They probably won't. Chances are that'd be fine. You guys still good over there? You guys all right? Yeah? You guys all right? Okay. All right, that's the last one we're going to do today. That was the last of the graph ones I asked you to do, right? Yeah. And so I asked you to do some of the rate ones, yeah? Yeah? I don't remember which ones I asked you to do, but do the ones I asked you to do. You guys already do the rate ones? Yes, no, maybe? You What? Rate FRQs for extra practice. Okay. I'll try to post that in the Google Classroom. Oh, weird. All right, well, rate FRQs for extra practice is what it's called, I guess, in the Google Drive. I'll put it up in Google Classroom. All right, that's it.